For lesson 6.2, we will take a look at the sampling distribution, center, and variability. There are two learning targets here. First, determine if a statistic is an unbiased estimator of a population parameter. So in other words, is the sample mean an unbiased estimator of the population mean? Is the sample proportion an unbiased estimator of the population proportion, and so on? And then we'll also describe the relationship between sample size and the variability of a given statistic. So let's take a look at objective number one. Okay, how would we know if the sample statistic is an unbiased estimator of a population parameter? A statistic used to estimate a parameter is an unbiased estimator if the mean of the sampling distribution is equal to the value of the parameter being estimated. So, in other words, we take the sampling distribution of, say, the standard deviation. Okay, so the statistic is the standard deviation. The parameter is the population standard deviation. Okay, so we want to know if the standard deviation of the sample can be used to, is an unbiased estimator of the population standard deviation. So we take the sampling distribution of the sample, okay, standard deviations of the sample, and then we find its mean. And then we compare the mean of that sampling distribution with the standard deviation of the population. If they are equal or close, then we say that the parameter or the statistic is an unbiased estimator. Now, here's one thing that you need to remember. Do not trust an estimate that comes from biased sampling method. For example, if you use voluntary sampling, if you use convenience sampling, okay, for example, then you do not want to trust that estimate. Okay, so what we want to do is um, to check whether the statistic from a simple random sample is an unbiased estimator. Okay, let's take a look at this problem. The manager of a grocery store records the total amount spent in dollars for each customer who makes a purchase at his store during a week. The values in the table summarize the distribution amount spent for this population. So these are the values, okay, in the population. So the population mean is 29.85, the population standard deviation is 24.63, and so on. So we have the records for the minimum, first quartile, median, third quartile, and the maximum. Okay, we want to know if the median is an unbiased estimator. So to investigate if the sample median is an unbiased estimator of the population median, 1,000 simple random surveys of size n equals 10 were selected from the population described. The sample median for each of these samples was recorded on the dot plot. So here is the dot plot for the sample median. The mean of the simulated sampling distribution is indicated by an orange line segment. So you see, here is the mean of the median, okay? The mean of the median for our sampling distribution. Now, does the sample median appear to be an unbiased estimator of the population median? Okay, so here is our mean. And the median of our population is 22.96, right? So this sample mean is very close to 22.96. So we say yes, the mean of the sampling distribution. So this is our explanation. The mean of the sampling distribution is very close to the median, very close to the median of the population, which is 22.96. And that's it. Now let's take a look. Try number 2 on your own. Okay. So here is the minimum. We're testing if the minimum is an unbiased estimator of the population minimum. This should be minimum. Okay, check your answers. To investigate if the sample minimum is an unbiased estimator of the population minimum, 1,000 SRS of size n equals 10 were selected from the population described. The sample minimum for each of these samples was recorded on the dot plot, and the mean of the simulated sampling distribution is indicated by the orange line. So I put down an arrow right here. Does the sample minimum appear to be an unbiased estimator of the population minimum? Okay, so here is the mean. It's like 5 point something. Okay, and what is the minimum of the population? The minimum of the population is 0.20. So 0.20 would be somewhere right here, right? And so we can say that no, the mean of the sampling distribution is clearly more than, way more, say way clearly, way more than the population minimum of 0.20.